So let's look at the point of view of a person inside. So viewed from an accelerating frame of reference. Right? How do things change? You saw when that video started, you had no idea, because you're inside the barrel and you're just looking to the people standing next to you, you had no idea that this thing has actually started turning. It's almost like we here on Earth, we know from other experiments that the Earth is evolving, turning around its axis, but I cannot figure that out by looking at either one of you, because our positions relative to one another remain the same. So for a person inside the barrel, so there's no idea that this barrel is rotating. All that they see is all of a sudden, here's the person again. All that they know is all of a sudden, they feel a force pressing them against the wall, and the wall presses back with a certain normal force. So here's some force that they just feel all of a sudden. Remember, they're inside the barrel, so they don't know they're going around in a circle. They just see everyone's position relative to themselves remain the same. All of a sudden, there's a force pushing them back against the wall. That's this force. Also, there is friction holding them up, and each one has got a weight, mg, holding them down. And the thing is, from the point of view of this person, this force seems to come out of nowhere. Right? They stand there, everything is suddenly, no position is changing relative to them. All of a sudden, they're just thrown back against the wall, and it feels as if something is pushing them back. And the reason, and this doesn't make sense, because there seems to be no cause of this force from this person's point of view inside the barrel. Right? If they don't know they're spinning, they're going to feel perhaps it's the ghost of Isaac Newton pushing them against the wall. And this is sometimes referred to as a fictitious force. I think my spelling is correct, but just forgive me if it's not. Because if you're in this frame of reference, so if you're inside the barrel, there's no way that you can figure out, but hold on, where does this force come from? And the short explanation of it is, it's due to your own inertia. So you've got mass, which means you don't like your motion to be changed. So this actually results from your mass. You don't like to change your motion. But the point that I'm trying to make is not to go into that detail too much, but to say, well, from this point of view, this is a non-inertial frame. And in non-inertial frames, if we apply Newton's laws, we get these fictitious forces that come out, seemingly from nowhere. It's not that they don't exist. To figure out exactly what's going on, you must just view this problem from an inertial frame. Then you know Newton's laws can be trusted, it works well. When you're in a non-inertial frame, so if you're accelerating, you do pick up spurious effects like this fictitious force, because you don't realize that you're actually viewing things from a frame that is itself accelerating. So that's what's meant by inertial frame. An inertial frame is just a frame of reference that is not accelerating with respect to any other frame of reference. So it's in frames like this that where Newton's laws are valid. So inertial frames. In non-inertial frames, we pick up these spurious effects that seem to us like being forces coming out of nowhere.